Hello students, this is SK Singh. Today we are going to discuss limit, which is very important part of mathematics, and limit is useful for continuity and differentiability also. So let's start. Limits. In this chapter, there are 7 indeterminate forms: 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 to the power 0, infinity to the power 0, and last one is 1 raised infinity. 0 by 0 means not exactly 0 by 0, approaching to 0 by approaching to 0, approaching to infinity by approaching to infinity. Similarly, approaching to 0, approaching to infinity, like this. So in this chapter, we will discuss about these indeterminate forms, and we will find determine value of the indeterminate form. So let us take an example. Evaluate limit x tends to 1, x square minus 1 by x minus 1. This is the very easy simple example. This can be evaluated by expanding or factorization method. So now if we put x is equal to 1 here, then we will get 0 by 0 form. So after factorizing, x square minus 1 means 1 square, x minus 1 into x plus 1 divided by x minus 1 cancel out, and then substitute x is equal to 1. So 1 plus 1, that is 2. 2 is the required answer of this limit. But value of this limit is not exactly 2, just approaching to 2 either from left or from right, when x approaching to 1 either from left or from right. So let's take next example. Evaluate limit x tends to 0, x sin x divided by 1 minus cos 2x. There are some formula which can be used in solving the limits of the function. Now this is also form, meaningless form of 0 by 0. X is equal to 0, 0, 1 minus cos 0, 0 cos 0 1, 1 minus 1 0, 0 by 0 meaningless form. So this can be solved by x. Sin x can be written as sin x by sin x and multiplied by x, and 1 minus 2 1 minus cos 2x can be written as 2 sin square x. So 2 sin square x, then limit x tends to 0, x square sin x by x divided by 2 sin x by x whole square into x square. X square cancel out, and we know that sin theta by theta 1 to 1 by 2 into 1 square, that is 1 by 2. Since limit theta tends to 0, sin theta by theta is equal to 1. Next example. Limit x tends to 2, x cube minus 2 cube divided by x minus 2. This is of the form 0 by 0, meaningless form. When we put x is equal to 2 here, 2 cube minus 2 cube 0, 2 minus 2 0. So this is of the form 0 by 0, which is meaningless form, indeterminate form. So we can factorize here x cube, and this is of the form a cube minus b cube, so a minus b into a square plus ab plus b square. This can be written as x minus 2 into x square plus x into 2 plus 2 square divided by x minus 2. X minus 2 cancel out. Now substitute x is equal to 2. So 2 square plus 2 into 2 plus 2 square, that is 4 plus 4 plus 4, 12. 12 is the required answer. But this factorization method is not applicable when exponent is more than 3, 4 like this. So if the exponent is 3 by 2 like this, then this method is not applicable here. So yeah, we can use here the formula limit x tends to a, x raised n minus a raised n divided by x minus a is equal to n a raised n minus 1. This is the very important formula. So we can write here limit, not limit, 3 by 2, here n is equal to 3 by 2, a is equal to 2, so 3 by 2, 2 to the power 3 by 2 minus 1, 3 by 2, 2 to the power 1 by 2, that is 3 by root 2. This is the answer of this question. Now prove this formula. Prove that limit x tends to a, x to the power n minus a to the power n divided by x minus a is equal to n a to the power n minus 1. We know that a plus x to the power n is equal to nc0 a to the power n plus nc1 a to the power n minus 1 into x plus nc2 a to the power n minus 2 x square plus dot dot plus ncn x to the power n. If n be a negative integer or a fraction and mod of x less than 1, then 1 plus x to the power n can be written as 1 plus nx plus n into n minus 1 upon 2 factorial x square plus n into n minus 1 into n minus 2 upon 3 factorial x cube plus dot dot to infinity. This is very important formula and useful formula. We will use this formula to solve, to find, to prove this formula. So since x tends to a means x is not equal to a. So either substitute x is equal to a plus h or x is equal to a minus h. So put or let x is equal to a plus h. As x tends to a, h tends to 0. Now LHS is equal to limit x tends to a, x to the power n minus a to the power n divided by x minus a can be written as limit h tends to 0, a plus h whole power n minus a to the power n by a plus h minus a. Plus a minus a cancel out. Now take a common from these two terms. Limit h tends to 0, a to the power n into 1 plus h by a whole power n minus a to the power n by h. This can also be written as limit h tends to 0, a to the power n whole divided by h into multiplied by 1 plus h by a whole power n minus 1. Now expand this expression by using this formula. limit h tends to 0, a to the power n by h 1 plus n h by a plus n into n minus 1 upon 2 factorial h by a whole square plus n into n minus 1 n minus 2 upon 3 factorial h by a whole cube plus dot dot to infinity dot dot minus 1 in the last. Plus 1 minus 1 cancel out. Now we can take h by a common. So take h by a common, limit h tends to 0, a to the power n divided by h multiplied by h by a common into n plus n into n minus 1 upon 2 factorial into h by a plus n into n minus 1 into n minus 2 upon 3 factorial divided by h by multiplied by h by a whole square plus dot dot. H cancel out. Here a raised n minus 1 multiplied by n plus, now all terms 0 because h is in every term. So all terms 0, then we will get n a raised n minus 1. So therefore limit x tends to a x to the power n minus a to the power n divided by x minus a is equal to n a to the power n minus 1 proved. Very, very important and useful formula of limit. Similarly, we can write your limit x tends to a x to the power m minus a to the power m divided by x to the power n minus a to the power n is equal to m by n a to the power m minus n. This is also a useful formula. So let's take an example. Evaluate limit x tends to 3 x raised 5 minus 3 raised 5 divided by x minus 3. Directly we write here 5 into 3 raised 5 minus 1, that's all. 5 into 3 raised 4, that's all. Now another example is evaluate limit x tends to 5 x raised 9 minus 5 raised 9 divided by x raised 4 minus 5 raised 4. With the help of this formula, we will find the value of this limit. 9 by 4, m is 9, n is 4, 9 by 4 into 5 to the power 9 minus 4. 9 by 4 into 5 to the power 5. This is the required answer. Now, let's take an example of another type. Evaluate limit h tends to 0 under root x plus h minus root x divided by h. This is of the form 0 by 0. 0 by 0 is meaningless form. Indeterminate form for this expression, this question. Now use your rationalization. So rationalize numerator. Limit h tends to 0 root over x plus h minus root x multiplied by root x plus h plus root x divided by h into root x plus h plus root x. In the numerator, a minus b into a plus b form, and we know that a minus b into a plus b, a square minus b square. So limit h tends to 0, this will be x plus h minus x divided by h into root x plus h plus root x. Plus x minus x cancel out. Limit h tends to 0, h upon h root x plus h plus root x. H cancel out. Now substitute value of h, that is h is equal to 0. Means x plus 0 plus root x, that is 1 by 2 root x. So in this type of question we will use rationalization. There are some useful expansions here. E raised x is equal to 1 plus x upon factorial 1 plus x square upon factorial 2 plus dot dot to infinity. E raised minus x is equal to 1 minus x upon factorial 1 plus x square upon factorial 2 minus x cube upon factorial 3 plus dot dot to infinity. E raised kx, replace x by kx, that's all, 1 plus kx upon factorial 1 plus kx whole square upon factorial 2 plus dot dot to infinity. E raised x is equal to e raised x log a base e or ln a is equal to 1 plus x log a base e upon factorial 1 plus x log a base e upon factorial 2 plus dot dot to infinity. Now prove that limit x tends to 0 e raised kx minus 1 by x is equal to k. This is the very useful formula of limit. We will use directly this formula in another question. LHS, limit x tends to 0 e raised kx minus 1 by x. Now expand e raised kx in terms of kx from this expansion. Limit x tends to 0 1 upon x e raised kx will be written as 1 plus kx upon factorial 1 plus kx whole square upon factorial 2 plus kx whole cube upon factorial 3 plus dot dot to infinity minus 1. Plus 1 minus 1 cancel out. Now take kx common from the bracket. Limit x tends to 0 kx divided by x multiplied by 1 upon 1 factorial plus kx upon 2 factorial plus kx whole square upon 3 factorial plus dot dot to infinity. X by x cancel out. Now substitute limit k 1 by 1, that is 1 plus 0. This is equal to k. Therefore limit x tends to 0 e raised kx minus 1 by x is equal to k proof. Now directly find the value of limit x tends to 0 e raised 5x minus 1 upon x is equal to 5. Limit x tends to 0 e raised 7x minus 1 upon x is equal to 7. Limit x tends to 0 e raised 2x minus e raised 3x divided by x. E raised 2x minus 3x divided by x. First of all, reduce this expression into this form and then use formula. So this can be written as limit x tends to 0 e raised 2x minus 1 minus e raised 3x minus 1 by x. Now we can write here limit x tends to 0 e raised 2x minus 1. Limit follows algebraic formula, algebraic rule. So we can write here limit x tends to 0 e raised 2x minus 1 by x minus limit x tends to 0 e raised 3x minus 1 by x. First one give 2 and second one 3. 2 minus 3 minus 1. So these are the example. Now prove another formula. Limit x tends to 0 a raised x minus 1 by x is equal to ln a or log a base e. A raised x can be written as e raised x ln a. So we can write here LHS. First of all, LHS limit x tends to 0 a raised x minus 1 by x, limit x tends to 0 e raised x ln a minus 1 by x. Directly we can write the value of this limit, because if we treat ln a as k, then this will be of the form e raised kx minus 1 by x. So this will be ln a. That's all. For example, limit x tends to 0 a raised x plus b raised x minus 2 by x is equal to limit x tends to 0 a raised x minus 1 plus b raised x minus 1 by x. Split this. Limit x tends to 0 a raised x minus 1 by x plus limit x tends to 0 b raised x minus 1 by x. A raised x minus 1 by x ln a, b raised x minus 1 by x ln b. So this is ln a plus ln b, and we know that log m into n is equal to log m plus log n. Ln m into n is equal to ln m plus ln n. So we can write here ln ab. Let's take some more examples. Evaluate limit x tends to 0 a raised x plus b raised x plus c raised x plus d raised x minus 4 divided by x. First of all, arrange this question in the form of limit x tends to 0 a raised x minus 1 by x, and write the answer. So a raised x minus 1 plus b raised x minus 1 plus c raised x minus 1 plus d raised x minus 1 all divided by x. Now I split x tends to 0 a raised x minus 1 by x plus b raised x minus 1 by x plus c raised x minus 1 by x plus d raised x minus 1 by x. Now here is the formula: ln a plus ln b plus ln c plus ln d. This is equal to ln a b c d. A b c d. This is the answer of this question. Let's take another example. Limit x tends to 0 a1 raised x plus a2 raised x plus a3 raised x plus dot dot plus an raised x minus n divided by x. Same as above question. So we can write here limit x tends to 0 a raised x minus 1 by a1 raised x minus 1 by x plus a2 raised x minus 1 by x plus a3 raised x minus 1 by x plus dot dot plus a raised n raised x minus 1 by x. This will be ln a1 plus ln a2 plus ln a3 plus dot dot plus ln an, which is equal to ln a1 a2 a3 dot dot an. This is the required answer. Now let's prove another formula. Ln 1 plus x is equal to x minus x square upon 2 plus x cube upon 3 minus dot dot to infinity, and ln 1 minus x is equal to all negative minus x square by 2 minus x cube by 3 minus dot dot to infinity. Now we have to prove that limit x tends to 0 ln 1 plus x divided by x is equal to 1. But just simply expand the expansion of logarithmic function and use the formula. LHS limit x tends to 0 ln 1 plus x divided by x, limit x tends to 0 1 by x, ln 1 plus x will be x minus x square by 2 plus x cube by 3 minus dot dot to infinity. Now take x common. So this is the value of this limit. Now evaluate limit x tends to 0 ln 1 plus 3x divided by x. Directly we can write the value of this limit, that is 3. Limit x tends to 0 ln 1 plus kx divided by x can be written as k. So that's all for today. We will discuss remaining part of limits in next class. Thank you.